The basic structural unit of the nervous system is the neuron, which allows for the transfer and reception of electrical pulses, which are important for information transfer. Neurons transfer information to the brain and spinal cord. They also transfer response information from the brain to the appropriate muscles. The neuron cell consists of an axon, dendrites, synapses, and the myelin sheath. The myelin sheath is the insulating material that surrounds the axon. It allows for the nerve's impulses to travel along the axon.
Potential difference between the extracellular space and the intermembrane region is achieved due to the diffusion of positive ions through the membrane. There is a greater concentration of positive charges outside the cell, causing voltage of -70 millivolts and therefore an electric field. Since the external and internal fluids are conductive, a current can flow inside or outside of the axon. Due to the potential difference between the extracellular space and intermembrane region, an electrical current is induced in the internal conductive fluid and allows for depolarization to move along the axon. The polarization timescale is determined by the time constant equation, where the time constant T equals the resistance of the myelin times the capacitance of the axon membrane.
The action of the nerve impulse through an axon can be demonstrated like a current in a circuit. The triggering of the action potential is like closing a switch connected to the battery. The interior fluid has a specific resistance, which can be determined by using the conductivity of the fluid, the axon radius, and the length of the axon. Since the axon is thin, the resistance is big. On the inside and the outside of the axon is conducting fluid, which is separated by an insulating membrane or a parallel plate capacitor in this case.
Once an action potential is triggered at the first node, the switch is closed, a current is induced on the circuit, and the capacitance of the membrane changes. When the voltage of the capacitor exceeds a certain threshold, going from -70 millivolts to -55 millivolts, another action potential is triggered at the next node. This is repeated until the action potential reaches the end of the axon. The speed of the propagation can be determined by the capacitance and the internal resistance. Eventually, after the action potential travels, the ion concentrations go back to resting levels and the cell turns back to -70 millivolts.